We're going to be talking about hypoxia trends in the South River, pretty much what we're seeing this summer season. So the things that we've been looking at since April into almost up until last week. So what we first want to talk about is actually the stations that we have here for those people who might not be familiar with what we're doing on the South River, because it's very comprehensive. So I think we'll let Diana talk about all of these stations plus the new ones we've added.
We have 21 stations in the South River. We have 7 main stem. So we added 2 from last year based on a discussion we had with the MTAC group. We needed 2 more main stem stations, and every single tidal tributary as far up as I could possibly get with still having some depth. So I usually don't go below 2 meters depth. These 2 are more bays rather than tidal creeks. The rest of them are traditional tidal creeks. Okay.
Right. We chose MS1. This is kind of important because this is right at the mouth of the South River. It's sticking practically in Chesapeake Bay. It's almost all the way out there. You can certainly see Thomas Point from there. And so it's kind of important to orient yourself in terms of MS1 being at the mouth and MS5 all the way at the headwaters, as we talk about mainly what's going on here in the Thalweg, or the main stem of the South River. These are the kinds of trends that we're interested in looking at. One thing that's also important, we do weekly sampling. Most of these stations we take every 0.2 of a meter depth for temperature, salinity, dissolved oxygen using the luminescent DO method, as well as chlorophyll A, blue-green algae. So we've got an awful lot of information. We're not going to look at all of that here. Well, we're going to focus mainly on DO because obviously DO is symptomatic of all of those things that we've been talking about. Let's take a look at April 22nd conditions for dissolved oxygen. Again, to orient you, we're looking at from the mouth of the South River going all the way up to the headwaters up in here. And we're just looking at those main stem stations. So if you take a look at what we're seeing here, at this time we've got some low dissolved oxygen, some of the hypoxic here near the mouth. Interestingly enough, if you take a look at the individual creeks at this time, the 2 creeks that are closest to it, Duval and Selby, actually had a nice little bloom occur and low dissolved oxygen coming out of those areas. Those areas are about 2 meter water depth, so where you start to see these fingers of low dissolved oxygen coming out. Whereas if you go further out here into the Chesapeake Bay, the conditions were actually fairly well mixed. So we're starting to see some, also there's some, if you take a look at the salinity, we do see that there's higher salinity here and lower salinity moving across. This area is going to be very important. This station 2, which is right next to which marina?
Liberty Marina.
Right next to Liberty Marina. This is going to be very important because we see an awful lot of the anoxic conditions developing in that particular spot. This is also the same spot where the Bay program does their sampling as well. I think WT 8.1 is where that site is. And so taking a look at the rest of this, this is very interesting up here where you start to see DO dropping very rapidly as well. And again, in terms of stratification, this is an area in here where we see a lot of medium strength stratification developing, mostly due to freshwater events that are coming out. We oftentimes do not see any stratification here, and usually very mild stratification. And this is critically important for the South River because unlike the main stem of the bay and some of the other tributaries, stratification seems to be very ephemeral. It comes and goes week to week, and actually there's some data that suggests that it can actually turn within the same day, meaning with a strong wind event you can have it well mixed, and then by the afternoon, 4 to 6 hours later, in certain spots, re-stratifying, and that has a significant effect for dissolved oxygen. So here, moving on to May 14th, again, looking not bad. Again, one of the big themes about this summer, 2 big themes, really, really hot. I think most people have experienced that. That's mainly controlled by the La Nina that we're seeing right now, but also very strong wind events that we've had. A lot from the south, a lot from the southeast wind events causing, we'll see numerous examples of the DO not looking all that bad. Again, here's May 28th, and you know, from top to bottom, looking pretty good for the most part. These are extreme wind events, and that's something that we need to think about in terms of our indicators, those kinds of things. What do you do with these extreme events? This is not usual to have so many days that are A, approaching 30 degrees Celsius, and B, having significant 16-knot winds, you know, week after week. That's something from the southeast, which, by the way, is the longest fetch for this area. So critically important. From the north, we'll see a different story entirely.
And again, on all of my data sheets, I write all the winds on there and where they're coming from, because when he goes and does data analysis for us, it's critically important.
By the way, you'll see here's sort of this generic bottom for the South River. You'll see some changes from time to time, depending upon how far we sampled down, as well as what the tidal stage was, whether we had extra low water or extra high water. You'll see that bottom change a little bit. So here's the classic bottom for the South River, July 6th. Again, if you take a look at here, it doesn't look bad at all. There is the beginning of some stratification that will develop even with salinity in this particular area. One of the main things that's going on here, although it doesn't look bad at all, one of the issues about sampling is that, you know, with 22 stations, you're not going to do this in 2 or 3 hours. You're going to be covering this within 6 to 7 hours. So which stations are being done in the morning time and what the wind conditions are versus which stations are being done in the afternoon has everything to do with wind conditions and tidal stage and the ultimate depth. So these guys have got to be done only on a flood tide. We can't get up in there.
I would have to prop dredge to get to this station, and that's due to the fact they put in Route 50, but they changed the hydrodynamics of Route 50 and made it very short channel, and then it opens up really wide, and since that time it's been silting in a lot, so in order to get to that, I have to get to it on a incoming tide or a flood tide. But again, that's on the data when we weigh that in, and then I just close my eyes and pick another station because I don't want to keep going to the same stations at the same exact time. So we vary it quite a bit.
Again, last year by this time we had started to see anoxia develop in this section right here, but it's not until, go ahead to the next one. It's not until about July 20th. Not only do we see anoxia, but look at how high up it is in the water column. And for those who were talking about the hypoxic squeeze, there's no better example than hypoxic squeeze right there. That's a great recipe for a fish kill, if you had fish in the South River.
And this is the time, again, when we're out in the water and we're wishing we have that breeze when it's 100 degrees outside and we don't get that breeze and it's hot. And this is what happens with no breeze setting up. So then we talk about what type of breeze or wind event do you need to stop the stratification in the South River.
Let's just leave it here for 1 minute. Take a look here by MS1, again near the mouth. Doesn't look bad. Again, we're not seeing low DO invading from the Chesapeake Bay into the mouth. What you're seeing appears to be growth from this deep station here and starting to spread out into these other areas. You're getting a weak to mild stratification developing here based on salinity, and even more stratification out here. Tends to be much better mixed in these areas. So if you're thinking about restoration projects, putting oysters in, you're probably going to want to target the creeks here rather than the creeks here. And it kind of makes sense for that, but it's important to figure those things out. Okay, here's July 26th, again showing pretty abysmal conditions in the same location. A little change in the shape. It's not quite as far up on Station 2. It's spread out a little bit more. Again, now this particular day was quite interesting and highlights something that's very important. July 26th, these stations were done in the morning, except for these ones out here. July 26th had a very strong wind from the north, extremely strong, a 16-knot wind, and this site was not stratified at all. So we continue to have anoxia despite the fact that there was no stratification, which again sort of begs these questions about in terms of, how strong is the low DO, how strong is the anoxia versus stratification, and how persistent it can be in the face of a strong wind. These are really important questions for modeling. Here's August. And again, we actually saw a reduction now. It's hypoxic, but not anoxic in that location. Moving up a little bit here. Again, looks pretty good out here. Here's August 16th. Fairly strong wind, I believe, in the morning.
Yeah.
So you're seeing that nice strong wind in the morning. By the afternoon, you might have started to see a little bit of stratification up in here, because this is when we were able to get up in here. So this is what I was talking about this day of, I noticed that, during the morning time conditions, a lot of wind, and then in the afternoon, it seemed to have stratified fairly quickly, at least in those low depth areas. So very interesting. Not an awful lot of rain, though, during that time. August 23rd, again, taking a look at fairly poor conditions, anoxic, hypoxic conditions returning. So again, it looks like this growth and decay over time. And if you match up in terms of what the chlorophyll is doing sometimes in terms of mid-depth maximums versus surface maximums, time of the day, and even the strength of the stratification, we start to get an idea of what may be happening with these particular areas. Also, recent data that we've collected showing that it's the phosphates that are really critical to this area. Very strong phosphate gradient with almost no phosphates out here and outrageously high concentrations here is probably what's driving an awful lot of this system. All right, and just then to get an idea of what I think is the next phase in terms of observing systems, and this is kind of important. Observing systems have been around for a while. It's what people want to do. But we've got a problem with observing systems. Either you're spatially intensive, but you have to compromise the temporal scale time, or you're good with satellite data, getting great both spatial and temporal, but you can't get depth. So what do you do with that? Well, what you guys have been doing is what you do. You try to go out once a week or once every other week. You try to pick a number of representative stations, and you try to get as many samples as possible. It's time consuming. It can get expensive. This can revolutionize everything. This is a REMIS. It's an autonomous underwater vehicle. It works completely by itself. I don't actually drive this. This is programmed. You program the coordinates in. You tell it what you want to do, what the course is. And then this is actually carried over from the Gulf War. We've put an optode, a dissolved oxygen sensor on this, and then a DO sensor based on luminescent DO. Each one of these things cost $400,000, and we have 6 of them. So we're a little heavy on these things. The nice thing about it is you put in transponders into your area. So this is done by acoustic signal. It flies the path for you. At any time you can kill it. Okay. And here's the first results. The first mission that we ran was actually in Round Bay. And just to give you an idea of what's going on, we took what we call a triangle path through Round Bay, this nice little zigzag path with dissolved oxygen. And what we're doing is actually here, you can see this path, we're actually at the surface, then we dove down with depth, then we came back up on the surface, so we're going up and down this way, showing what the dissolved oxygen is doing, just to get an idea of what this instrument can do. And then there was one track, this one here, this one right here, where we actually were able to fly it up and down like this. So we're trying to get an idea of how well the DO responds in terms of the response time. This thing is driven at 4 knots, and it traversed this area in 2 hours. So we can actually do the entire Severn River down and up in about 2 hours if we wanted to do something like that. Dramatically cuts down on time. It also has a CTD package on it, so you're getting all the same things that you guys have been collecting, plus acoustic Doppler current meter and side scan sonar. And the new one, well, the 6th one that we're about to get, we hope to get the EcoPuck attached to it, which is chlorophyll A and turbidity.